Welcome to the DIY Honda Garage channel. In this presentation, we will be addressing Diagnostic Trouble Code P0108, which indicates a high voltage in the manifold absolute pressure MAP sensor circuit for the Honda CRV models between 2017 and 2022. The DTC signifies that the electronic control unit, ECU, has detected an abnormal voltage reading from the MAP sensor, which is crucial in determining engine load and performance. This sensor plays a key role in engine management by providing data to the powertrain control module, PCM, assisting in fuel mixture calculations for optimal combustion. The locations of the MAP sensor can typically be found near the intake manifold, where it can accurately assess intake manifold pressure. Knowing the components, their functions, and their locations is vital for effective troubleshooting. DTC P0108 indicates that the manifold absolute pressure MAP sensor is reporting a high voltage, suggesting a potential malfunction within the sensor circuit. The MAP sensor's role is critical for the vehicle's air-fuel mixture regulation. Thus, accurate data is vital for the engine's performance. The affected components are primarily the MAP sensor and the powertrain control module, PCM. The MAP sensor is typically located near the intake manifold on the engine, allowing it to measure the pressure inside the intake manifold effectively. Any abnormalities in its function can lead to improper fueling, reduced fuel efficiency, and increased emissions, potentially triggering a check engine light. Hence, addressing this DTC promptly is essential to maintain optimal engine function. There are several potential causes of DTC P0108 that a technician should be aware of. First, a faulty MAP sensor itself may produce high voltage readings, as it can wear out over time due to heat and vibration. Second, wiring issues such as breaks or shorts in the harness connecting the MAP sensor to the PCM can lead to incorrect voltage readings. It's critical to inspect wiring for signs of damage and secure connections to prevent intermittent faults. Additionally, poor connections, such as loose or corroded terminals at the MAP sensor and the PCM, could disrupt the voltage signal, leading to a high voltage reading. Comprehensive troubleshooting should consider all these variables to accurately pinpoint the malfunction. When DTC P0108 is present, certain symptoms may manifest, alerting the driver to underlying issues. The most prominent symptom is the illumination of the check engine light, which serves as a warning that the engine management system has detected an anomaly. Poor engine performance can also be observed, as the high voltage reading from the MAP sensor might disrupt the air-fuel mixture, leading to rough idling, reduced acceleration, or stalling. Additionally, increased emissions may occur as the engine attempts to compensate for incorrect readings, possibly resulting in failing an emissions test. Recognizing these symptoms can assist in timely identification and repair of the DTC, ensuring a smooth and efficient vehicle operation. The initial step in troubleshooting DTC P0108 involves the use of the HDS, or Honda Diagnostic System, to assess the status of the MAP sensor. First, you'll want to turn the vehicle to the on mode without starting the engine. This allows the HDS to communicate and retrieve live data from the MAP sensor. Specifically, observe the voltage in the data list for the MAP sensor. It should not exceed 4.49 volts. If the current conditions match the specified threshold, this indicates no immediate issues with the sensor. However, if the voltage reading is higher than 4.49 volts, it suggests a fault either in the sensor or its connections. Proceed to subsequent steps based on these readings to diagnose further. In this step, you will verify the integrity of the MAP sensor connections by checking the voltage readings directly. Begin by turning the vehicle to the off mode and disconnecting the map sensor's 3P connector. Once removed, you will then connect terminals A and B of the connector using a jumper wire, effectively bridging the circuit. After verifying the connection, turn the vehicle to the on mode again and check the map sensor voltage with the HDS. The reading should remain above 4.49 volts. If it does, this indicates that the map sensor may be functioning correctly and the issue could lie elsewhere. If the conditions do not match, it's advisable to replace the map sensor before proceeding further. Proceeding to this step, you will measure the voltage across specific test points in the map sensor circuit. First, ensure the vehicle is in the off mode and then remove the jumper wire from the connector. Once again, turn the ignition to the on position. At this juncture, it's important to measure the voltage between test points 1 and 2 on the map sensor 3P connector, which will provide vital insight into the wire's functionality. You are looking for a reading of approximately 5.0 volts. If you obtain this reading, the power supply circuit appears to be intact, and you can move on to the next steps in the troubleshooting process. If there is no reading or it deviates from the expected voltage, further investigation into wiring and connections is warranted. At this point, focus on the continuity of the SG1 wire, which is crucial for the proper function of the map sensor. First, ensure the vehicle is turned off. Then jump the SCS line with the HDS and wait for more than 1 minute before proceeding. Afterward, disconnect the PCM connector E, which has several essential terminals for circuitry. Use a multimeter to check for continuity between test points 1 and 2. If continuity is confirmed, meaning the wire connects effectively, the SG1 wiring is likely in good condition. However, if continuity is absent, there is likely an open circuit in the SG1 wire that needs to be repaired between the PCM and the map sensor before moving forward with the diagnostic process. Continuing with the troubleshooting process, this step involves checking the continuity of the PB wire. Again, start by ensuring that the vehicle is off. Utilize the HDS to jump the SCS line, allowing for optimal conditions to check the circuit. Next, disconnect the PCM connector E, just as done previously. You'll then check for continuity between the second test point of the map sensor connector and a specific terminal in the PCM connector E. A successful continuity reading indicates that the PB wire is functioning correctly. However, if there is no continuity detected, it signals a break in the PB wire that requires immediate repair to restore proper communication between the map sensor and the PCM. After completing all necessary repairs related to DTC P0108, it's crucial to undergo a final inspection to confirm that the issue has been resolved. Begin by clearing any stored Diagnostic Trouble Codes, DTCs, from the vehicle system using the HDS. Following this, perform a test drive to ensure that the vehicle operates normally under various conditions. After the test drive, recheck the map sensor's readings with the HDS to ensure that the voltage levels are within the acceptable range and that no new DTCs have appeared. This final verification step is essential to validate that all repairs were successful and that the vehicle is running as intended. If the DTC reoccurs, further investigation may be necessary. To prevent future occurrences of DTC P0108, it is essential to establish a routine maintenance protocol focusing on the key components involved in this diagnosis. Regularly checking the electrical connections related to the map sensor and the PCM can help catch issues such as corrosion or loose terminals before they cause faults. Additionally, inspecting the wiring for any frays, breaks, or signs of wear can prevent potential signal interruptions. Should any components show signs of wear or malfunction, timely replacement can simplify service in the future and maintain efficient vehicle operation. By adopting these preventive measures, technicians can significantly reduce the risk of running into DTC P0108 and ensure a healthy engine management system. In conclusion, thorough understanding of the MAP sensor's function and its role within the engine management system is essential when diagnosing DTC P0108. Each troubleshooting step must be approached methodically to ensure that all potential issues are addressed, from improper signaling to faulty wiring. By systematically verifying the sensors and connections, technicians can accurately identify the root cause of the problem, leading to effective repairs. Furthermore, implementing preventive maintenance practices can help avoid this DTC from reappearing in the future. Remember, prompt attention to DTCs not only ensures the longevity of the vehicle, but also enhances the overall driving experience. Please like and subscribe to the channel. See you next time.